here we're doing day 7, solving systems of inequalities. And we have done the majority of this packet now. And as you've seen, it's just all systems of equations, okay? So we're taking it one step at a time. We learned how to solve just a regular equation, linear equations, and then we learned to graph those equations. And then we learned to graph inequalities. So now we're taking a step further. Now we have solving systems, which we learned to do with either elimination or substitution. We learned how to then graph those equations. And so today we're going to learn how to solve a system of inequalities. And it's very similar to how we graphed inequalities back I think in Unit 4. It's pretty much the same exact steps. So let's start typing in what we got. So there are two additional things to think about when graphing inequalities. Recall, they are either dashed or solid lines. That's the first thing that we need to recall. And which one is which? Which one is which when thinking back on this? Well, again, recall it dashed. That was either with greater than or equal to, or less than or equal to. And that's completely backwards. Let's get rid of that because I'm not paying attention. That's only with greater than or less than, not the equal to's. So if you wrote that down, make sure you make that change. I apologize. Greater than or less than. The solid lines, those are the ones where it's either greater than or equal to or less than or equal to. Okay? So we do the dashed or solid lines, and then we also have to do the shading. Right? Dashed or solid, and then we need to determine where we're going to shade. But then recall, how do we know where we're going to shade on the graph? Well, we need to pick a test point. We got to pick a test point. And what we did in the previous unit, we used the same test point every single time because that is what makes it easy. We always used 0, 0 for our test point. Okay? 0, 0, where x is 0 and y is 0. Third step, to identify that solution, we placed an S in the area that was shaded. So in this case, we're going to have two different equations or inequalities to graph, and we're going to want to place an S in where it's double shaded. So where did we shade for both, and where did those shadings cross? To check our answers, we choose a point that falls within the double shaded, the double shaded area. Okay. Okay. Let's see. Let's do number 1 together. And we're actually going to do all of them together, so it doesn't really matter. Graph the following systems of inequalities and indicate the solution. Well, let's see. We're going to, if you guys have highlighters or different colored pencils, markers, this lesson is going to be very nice to use those different colors, okay? Just because we have two different inequalities, equations going on here now. So we want to keep color-coded. So let's take a look at this. Let's graph this. Well, the first thing I'm looking at, am I graphing a solid or a dashed line? Since it's greater than or equal to, it's going to be a solid line. But it's not an equation. It's not y equals mx plus b. It's just x. Well, also recall VUX, right? Where VUX stood for vertical line, undefined slope, and x equals, right? And that's how I know it's going to be a vertical line, because its x is greater than or equal to 2, so I know that there's an x involved. Let's erase this. it's going to be a vertical line at 2. Well, let's graph this again. It's going to be a solid line too. So I'm going to pull out the line. Again, yours should have arrows on them. Okay, yours should have arrows, but since I'm doing this on a laptop, it's kind of hard to do. And actually what I'm going to do is I'm going to use the blue one just to stay consistent with the colors. That's the only reason I'm using this blue line here. Okay, so there we go. Greater than or equal to 2. And then y is less than negative 2. Let's use red for that. Y is less than negative 2. Well, again, that's going to tell me it's going to be a dashed line. And if it's y, that tells me it's also hoi, where the h stands for a horizontal line. And the y stands for y equals. So let's graph this at y is negative 2. So recall, here's my x, here's my y. So we're looking for y and negative 2. So I'm going back to my line. I'm going to use this. Negative 2, holy cow. We don't want that. That looks awful. I wonder if there's another way I could. Doesn't look like I can. But not a huge deal. There's y is less than negative 2. I'm just going to label these. Y is less than negative 2. And this was x is greater than or equal to 2. Now, we need to figure out, where am I shading? Where are going to be my shading points? Right? So I need to pick my test point. And we say that my test point, again, it's going to still be 0, 0. That's always going to be our test point. So my test point is 0, 0, where 0 and 0 are x and y. So I'm using this inequality. X is greater than negative 2. Greater than or equal to. So I want to substitute in 0 for x. So is 0 greater than or equal to 2? Well, no, it's not. That's false. Recall that. It's false. So that means that I want to shade away from my test point. I want to shade away from it. So I should put an x where my test point is. That way I know which way I'm going to shade. And since this is false, I'm going to shade away from the test point. So I'm looking at x is greater than or equal to 2, which is this blue line. And that tells me I want to shade the opposite way of the test point. So I'm not going this way, but I'm shading here. Right? All this. And then I got to repeat the same process for y is less than negative 2. So I want the test point of 0, 0 still, which is x and y. And I'm going to use this piece now. So is 0 less than negative 2? Well, no, it's not. I mean, yeah, 0 less than negative 2. That's correct. So, no, it's not. Negative 2 is not bigger than 0. So that means that I am going to shade away from my test point at y is less than negative 2. So I'm going to shade this way now. Now, if you see here, the colors are not going to go through each other, but this is where I double shaded, only in this area here. So therefore, that has to be my solution, right? And if you guys saw what I messed up here, this should be a dashed line, right? Because it's less than negative 2, and I even put dashed before, but it's kind of hard on the computer. Let's just say, there's my dashed, if I did this right. dashed line there. Okay, so my solution is all in here. Right, and then I want to put a big S in there. S4 solution. All right. To check, to see, we just want to pick a point inside. Any point in here, any point that's X and Y. Let's see, 1, 2. I could pick 3, 1, 2. I could pick 3 and -3 if I wanted to do my check. All right, I just want to see if 3, -3 worked. X and Y. Well, if I tested it out, is 3 greater than or equal to 2? Yes. And is -2 greater than -3? Yes. And I got those straight from here, X and Y. Here's my X, here's my Y. They both worked, so we are good. All right, on to number 2. Same process, okay? I'm going to use blue for the top and red for the bottom. So the first thing I'm looking at, is it solid or dashed? Well, that's solid, that's solid. They're both going to be solid, which is good because I can actually graph those pretty nice on here. So I can't graph x plus y is greater than or equal to 4. Why not? Well, y isn't by itself. I'm going to have to get y by itself by subtracting x to both sides. X cancels out. Y is greater than or equal to, I'm putting the x first because of mx plus b form. Y is greater than or equal to -x plus 4. Sweet. Instead of even graphing this right now, let's get the test point out of the way as well. That way we can do everything at once. So my test point of 0, 0, which is x and y. So y is going, or 0 is going in for y here. So is 0 greater than or equal to, 0 is going in for x, so that's just going to be 0. So is 0 greater than or equal to 4? No, it's not. 0 is not greater than or equal to 4. I want to put an x where my test point is. Okay, so that's cool. Let's find the other inequality. That way we can graph them both at the same time. Oh, look at that. Y is already by itself. Y is less than or equal to 2x minus 3. That's awesome, saving me some work. But I still want to try my test point of x and y. So I'm going to substitute in 0 for y. So is 0 less than or equal to 2 times 0, it's just 0, minus 3? Is 0 less than or equal to -3? No, 0 is not less than -3. That's also false. Okay, so that tells me when I graph these, which I'm going to have to do now, that tells me I'm shading away from 0, 0, wherever I graph these. So I'm going to graph this one first. My slope is -1/1. My y-intercept is +4. The y-intercept tells me where I'm starting. So I'm starting at 4 up. 1, 2, 3, 4. And then my slope is -1/1. So I'm going down 1 to the right 1. Down 1 to the right 1. All the way down. And I want to finish it going this way, so I'm going opposite. Up 1 to the left 1, up 1 to the left 1. And then we want to graph it with a nice line. And this is going to be a solid line. They're both solid, so that is nice for the computer. Remember, this should have arrows. I just can't do it on the computer. Make sure you're putting arrows on your lines, though. So this is y is greater than or equal to -x plus 4. We did the test point, and we determined that it's false. I'm not going to shade towards the test point. I'm going to shade this way. So I'm going to pull back out my blue pen, and I'm going to start shading this way. Okay? Now, let's graph y is less than or equal to 2x minus 3 in red. Well, my slope is 2 over 1, and my y-intercept is negative 3. So that means I'm starting at negative 3 on the y-axis. 1, 2, 3. My slope is positive 2 over 1. So that means I'm going up 2 over 1. Up 2 over 1. Same thing going backwards. Down 2 over 1. Down 2 over 1. Okay? Now I'm going to connect that with a nice line. Right here. Get this right about... No, that looks bad. That's not going to work. Undo. Let's try that again. Right about there. That's good. Okay, sweet. Let's label our lines. That way I know which one is which, even though I kind of have blue and red. This one was x plus y is greater than or equal to 4. And then this one was y is less than or equal to 2x minus 3. Now, I have them labeled. My test point, where am I shading for y is less than or equal to 2x minus 3? Well, I got false, right? So I'm not going to shade towards my test point. I'm going to shade away from it. So that means I'm going to be shading all this. All in there. Now take a look at where the double shade is. This is my solution area right here, where the blue and the red are shaded in together. And that's big, okay? That is my solution set. This is my solution area. Big S. That's an S right there, okay? So any point in here, in this quadrant or in this little shaded area, is a solution to this system. So for example, positive 1, 2, 3, 4, 5, comma 1. Yeah, that's a solution. 5, comma 1 is a solution. And you could check that. I urge you to. For the sake of the video, I'm going to skip it and go on to the next question. So here's my answer, that shaded area there. Let's go on to back page. We have y is less than 3/5 x plus 4, and then negative 3x plus 5y is greater than or equal to negative 5. Okay, I want to graph both of these. First thing I need to determine, am I going to have a solid or dashed line for both? This tells me I'm going to have a dashed line, and this tells me I'm going to have a solid line. Okay? Again, I'm going to do the first one in blue and the second one in red. So let's take a look at this one. Y is less than 3/5 x plus 4. Now, do I have to do anything to this to graph it? No, I don't. It's already in y equals mx plus b form. So this is ready to graph. Let's do the test point quick. A test point of 0, 0, x and y. So I'm going to substitute in these zeros for x and y. Is 0 less than 3/5 times 0 is just 0 plus 4. Is 0 less than 4? Yes, true. So that's our first true. That means whenever I graph this, I'm going to be shading towards my test point, towards my x. Okay? Now, let's do the second equation in red. Okay, so this one's going to be down here. This one, I'm going to have to do a little bit of work to get y by itself. Okay? Trying to get y by itself. Well, the first thing I'm going to do is add 3x, because that's a negative, okay? I'm not going to subtract it if it's a negative. I want to cancel it. Well, negative 3 plus 3 would cancel this out. So what I do to one side, I got to do to the other. Again, this would cancel out. I'm left with 5y is greater than or equal to 3x minus 5. Almost there. I got to get rid of this 5 here. So divide by 5 on both sides. So then y is greater than or equal to 3/5 x. 5 over 5. That's just 1, right? Minus 1. Okay, sweet. Let's do our test point. TP of 0, 0, x and y. So 0 is going in for y. Is 0 greater than or equal to 3/5 times 0 is 0 minus 1? Well, let's see. Is 0 greater than or equal to negative 1? Yeah. 0 is greater than negative 1. So that means I'm going to shade both of my solutions, both of my systems, towards my x here, towards my test point. Now, let's actually graph these, though. Going back to blue, because we're going to do this one first. Again, this is going to be a dashed line. Let's make sure of that. So my slope is 3 over 5. My y-intercept is positive 4. So I'm going to start with my y-intercept. 1, 2, 3, 4. Going up 3, 1, 2, 3, over 5. Can't do that again. It's going to go off the graph, so let's go backwards. Going down 3, 1, 2, 3, to the left 5. And again, I'm not going to be able to do anything with this. So what I'm going to do is I'm going to do a straight line. Okay. Oh, whoops. No, I don't want that. I'm going to do a straight line, and I'm just going to like sketch in little lines to indicate it is supposed to be a dashed line. On your page, you should be able just to do a straight dash line. Okay, so here are my little dashes. These should be dash lines. Now, let's do the shading. My test point was true. So at 0, 0, it's true. That means I want to shade towards my test point. All this stuff here. Let's graph the other one. Negative 1. Y is greater than or equal to 3/5 x minus 1. Well, let's see. My shading kind of messed this up, but that's okay. Here at negative 1, I'm going up 3 and to the right 5. Can't go anymore. I'll go down 3 and to the left 5. And again, that's going to be a solid line, so I can connect that with a nice line and not feel obligated to put dashes because it's not dashes. Okay. Now I have to shade this line, which again, it's true. So that means I'm going to shade towards my test point of 0, 0, which is everything going this way. Right? Everything in here. Oops. That's okay. Get rid of that. So, where's my solution here? Well, let's use green again. My solution is right in the middle here. It's everything in the middle where we shaded both. That is my solution, my big S. Okay? All right, last question. Try and make this one quick. Graph the system of linear inequalities. We have 3 different linear inequalities, so we're going to need 3 different colors. So we'll do this one with blue. We'll do the second one with red, and then we'll do the third one with green. So, how do I graph this first one? Well, recall x greater than or equal to 2. That's going to be Vux. All right, so it's going to be a vertical line at 2, and it's going to be a solid line because it's greater than or equal to, so that's nice. Let's graph this one. I'm going to get my line. At positive 2, I'm going to get a vertical line, so that's going to be here. Okay. Try and mimic nope. Undo. We'll just write x is greater than or equal to 2 there. Okay, let's graph this one. Y is greater than or equal to negative 3. Y is greater than or equal to negative 3. Well, this is going to be hoi. So it's going to be a horizontal line at negative 3 on the y-axis. Negative 3 is going to be here. Let's write y is greater than, is it greater than? Yeah, y is greater than or equal to negative 3 here. And then the last one, x plus y is less than or equal to 4. Well, hopefully you see we can't graph this yet because it's not in y equals mx plus b form. So we're going to have x plus y is less than or equal to 4. Got to get y by itself. Let's subtract x from both sides. Cancels out. And y is less than or equal to negative x plus 4. Now I can graph this. I got my slope. I got my y-intercept. Let's go ahead and graph this. So I'm starting at positive 4. That's my first point. 1, 2, 3, 4. And my slope is negative 1 over 1 because it's negative x. So I'm going down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. So on and so forth. And then up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1. Again, it's going to be a solid line. Let's connect this. Just like so. Make sure you guys are putting arrows on yours. I'm just not because it's very hard on the computer. And again, this is going to be, what is this line? The original equation was x plus y is less than or equal to 4. Okay, we have all 3 of these graphed, but how do I know where I'm shading? I got to do my test points for each one. Let's start with my first equation. X is greater than or equal to 2. Let's do it over here. Again, I'm using a test point of 0, 0. So when x is 0, is 0 greater than or equal to 2? No, it's not. That's false. So it's going to go away from the test point. Let's do the next one, which is y is greater than or equal to negative 3. Test point of 0, 0. So is 0 greater than or equal to negative 3 here? Yeah, that's true. So that means that we're going to shade towards the test point for the red. And then the last one, which is x plus y is less than or equal to 4. So is x plus y, less than or equal to 4. Apologies. Test point of 0, 0. So x, y, 0 plus 0. So is 0, less than or equal to 4? Yes. Yes, it is. So I'm Xing my test point. And now we have everything we need to start shading. Let's start with the first one. I'm starting at x is greater than or equal to 2, which is this vertical line. And since it's false, that means I'm shading away from the x, away from my test point. So it's going to be shaded all over here. Now, let's go to the red one. Y is greater than or equal to -3. And that's true, so that's this line here. Y is greater than or equal to -3. So since it's true, I'm going to shade towards my x. So it's going to be everything above y is greater than or equal to -3. Okay, all this stuff. Last one. X plus y is less than or equal to 4. So let's see. This was true, which means I'm going to shade. I'm here. This is my line. Right here. So I'm going to shade towards my test point, which is everything to the left of this line. Right, everything going this way. So this just looks like a whole mess if you take a step back and see everything here. This is very hard to see, right? But in one section, there is a section where all 3 parts are shaded. And if you can't see, I will show you right here. That one section is this triangle right here. Nope. I don't know what just happened. That's odd. This triangle right here. Right? Everything in here. As you can see, there's all 3 shaded. So, I'm not going to go ahead. Actually, no, it's easy. This is actually an easy 3 questions. Describe the shape of the solution region. Well, the solution region looks just like a triangle. Find the vertices of the solution region. That just means the points of the triangle. So it's these 3 points here. Okay, 1, 2, 3. Part B is good. And then find the area of the solution region. I don't know if that means to put an S in here or find the actual area, but we're not finding the area of the triangle. Okay? And that is day